You can clearly see the thruster firings as the HTV-X1 holds position at the 250-meter mark. This is the brand new cargo ship from the Japan Aerospace Exploration Agency, launched from the Tanegashima Space Center on Saturday night U.S. time, Sunday morning Japan time. We're in a handover between satellites on our tracking and data relay satellite system. The International Space Station is currently crossing the coast of Washington State, moving from northwest to southeast. A good view of HTV-X1. The flight control teams are discussing the status of the vehicle's systems in preparation for a go-no-go poll to resume its approach to the next hold point of 30 meters and to continue with an approach and retreat demonstration. HTV-X moving in concert with the International Space Station at a speed of about 5 miles per second, but in relative distance to each other, currently holding at 250 meters. A final systems check is being conducted by the JAXA engineers at the HTV Control Center in Tsukuba, Japan. Once HTV-X is berthed to the nadir port, the Earth-facing port of the Harmony module, its parking place will be right next door to the Northrop Grumman Cygnus cargo craft, which is mated to the Earth-facing port of the Unity module. HTV-X1 flying over the Rockies, moving towards the southeastern quadrant of the state of Colorado. The visiting vehicle officer here in Mission Control reports that the next pair of demonstration tests, the LiDAR sensor demonstration and the hold and retreat demonstration, will be conducted here shortly. Again, that data is valuable to ensure that the HTVX can retreat away from the station on crew command if required in the event of a systems issue that would crop up in the terminal phase of this rendezvous. Each of these demonstrations expected to last about 5 minutes in duration. HTVX-1 and the International Space Station now crossing the border between Oklahoma and Texas. HTVX-1 just about to pass off the coast of Louisiana. Again, flying from northwest to southeast, an evaluation of LiDAR sensor data is underway. This is navigational data that updates the HTVX's computers regarding its relative range away from the space station and its rate of closure once that resumes a short time from now. This view from external cameras on the International Space Station showing Hurricane Melissa. It is currently packing winds of 105 miles an hour as it moves north-northeast at a speed of 14 miles an hour, departing southeastern Cuba after wreaking havoc and devastation on the western portion of Jamaica yesterday with record winds of 185 miles an hour. Again, a view from an altitude of 260 miles as the space station flies just to the west of Hurricane Melissa. This is Mission Control Houston, back to a view of the HTV X1, holding at 250 meters, about to continue on, pending approval by Flight Director Fiona Antkowiak here in Mission Control. Flight Director Fiona Antkowiak here in Mission Control is completing her poll of her flight control team before informing the HTVX Flight Director in Tsukuba, Japan. Next up will be the retreat performance demonstration, where the crew will be sending retreat commands from its post in the cupola. This occurring prior to HTVX entering the keep-out sphere. Once again, the HTVX cargo craft, the brand new cargo craft from the Japan Aerospace Exploration Agency, still holding steady at 250 meters, about to be given approval to conduct a retreat demonstration, essentially a test of an approach abort capability should that become necessary. One of several hold points and demonstration points, as the HTVX resides at the moment directly below the International Space Station.
Station Houston on 2 for HTVX. SIPC and MCC Houston are ready for the HTVX approach from 250 meters. Expect approach to resume shortly and stand by for the retreat demo.
Copy. Expecting the approach to resume shortly, and we will also expect the retreat demo.
Good copy.
Aki Hoshide, the spacecraft communicator, informing Zena Cardman aboard the station that all of the flight control teams are go for the resumption of approach to the station from 250 meters and for the retreat demonstration in which Cardman will be sending commands to HTVX to essentially stop and back away and then resume approach, testing its capability to perform that function should it become necessary. HTVX at the International Space Station, flying 260 miles over northwestern Brazil. Moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. Cardman is joined in the cupola by JAXA astronaut Kimiya Yui, who will be at the controls of the station's Canadarm2 robotic arm to reach out and grapple HTVX once it arrives 10 meters away from that capture point. And HTVX now back on the move, resuming its approach from 250 meters.
Station Houston on 2 for HTVX. HTVX has resumed approach from 250 meters. Per step 3 in 1.102, you are go to arm the retreat command, then command retreat when HTVX range is 225 meters. How copy?
Okay, copy. HTVX has resumed the approach, and we are go in step 3 for the retreat command. We will issue that command when we are at prior range 225 meters.
That's a good copy.
Now standing by for the crew to issue the retreat command. The retreat command has been sent.
Houston station for HTVX. Pry range is 241. We have issued retreat ready. Retreat arm is flashing. We will be ready at pry range 225 for the execute command.
Copy and concur.
HTVX now in a planned retreat. This is a crew command from the cupola.
Houston station, retreat command has been executed. We see go to retreat point for the visiting vehicle submode and good lights on the HTVX command panel.
Copy all.
Good response by HTVX, reported by Zena Cardman, confirmed by the flight controllers here in Houston.
Station Houston on 2 for HTVX. HTVX is in retreat mode. Expect HTVX to slow its approach, then retreat to 250 meters.
Copy. We see HTVX in retreat mode, expecting its rate will slow and then it will retreat to 250 meters.
Good copy.
HTVX performing as advertised. This is the final major near-field demonstration of the HTV's systems prior to its moving into the keep-out sphere to the next hold point at 30 meters away from the International Space Station. We are standing by for the completion of this retreat demonstration prior to HTVX resuming its approach up the radial vector towards the station and an eventual grapple point just 10 meters away from the international outpost. HTVX currently flying in formation with the International Space Station off the coast of South America, moving from northwest to southeast over the South Atlantic. The retreat demonstration based on crew command from the cupola has been completed and is met the pass-fail criteria. So the evaluation is continuing here in the flight control room as HTVX is poised to resume its approach for its capture with the space station's robotic arm. We are standing by for the final approval from Flight Director Fiona Antkowiak to resume approach from 250 meters. This slow crawl up the radial vector is deliberate to test the HTVX's systems prior to its arrival in close proximity to the station for its eventual grapple by Kimi Yui of the Japan Aerospace Exploration Agency using the station's robotic arm.
Station Houston 2 for HTVX. Confirm 250 meter hold per step 4 in 1.102.
Copy. Working step 4 to confirm 250 meter hold.
Good copy.
And with that call from Aki Hoshide to Zena Cardman, the retreat demonstration is now complete.
Confirm per step 4. Good 250 meter holds. All lights on the HTVX command panel match, and visiting vehicle mode and submode and prior range are good to go.
Copy all, thanks.
So the retreat demonstration is complete, and HTVX has passed all of its criteria for all of its near-field demonstrations at this point. We're expecting the resumption of approach to the station to commence shortly. This is Mission Control Houston, a good view of the HTVX cargo craft, which is about to resume its approach to the station for its capture and berthing on a common berthing mechanism on the Earth-facing side of the Harmony module later today. HTVX has been holding steady at 250 meters away from the station, just completing its retreat demonstration, where it accepted commands from the crew on board from Zena Cardman and Kimiya Yui in the cupola to test its ability to back away from the station in the unlikely event a systems issue would crop up. Now back at 250 meters, we're just moments away from a final go from Flight Director Fiona Antkowiak to resume approach. This is the view from the end effector camera on the International Space Station's Canadarm2 robotic arm, showing the position of HTVX relative to the station at a distance of 250 meters. HTVX will resume its approach from the 250-meter mark momentarily.
Just wanted to give you a status. So with the Lighter 2 issue that we're having, we're going to perform some troubleshooting while at 250-meter hold. So that takes about 10 minutes or so. We'll give you a call when we're ready to resume.
Okay, copy all. We'll expect maybe 10 or so minutes of troubleshooting here at the 250-meter hold.
Good copy.
The troubleshooting referred to by Aki Hoshide in that communication to Zena Cardman aboard the station, referring to some erratic data that is being acquired from one of the two redundant LiDAR sensor systems that provides updated navigational data to the HTVX's onboard computers. However, this is not expected to be an impediment to the resumption of the approach of HTVX for its ultimate capture by the robotic arm. And again, this is a view from the end effector camera on the arm itself, the view that we'll be zooming in on as HTVX is ready to be captured. The arm will be operated by JAXA astronaut Kimiya Yui. The clocks here in Mission Control currently being updated for the various milestones that are ahead We're probably about 21 minutes away from departing the 250-meter mark and about an hour and 37 minutes away from its capture. The original capture time was pegged at 10:50 a.m. Central, 11:50 a.m. Eastern Time. However, there's nothing magic about that time. We have all the time in the world today, since the crew does not plan to open the hatch to HTVX and begin to unload its cargo until tomorrow. This is Mission Control Houston, continuing to watch the HTVX, the Japan Aerospace Exploration Agency's new cargo craft that is sitting rock steady, about 250 meters away from the International Space Station. HTVX and the station flying in formation just to the southeast of the southern tip of Africa, about to begin a southwest and northeasterly trajectory across the Indian Ocean. We are standing by for final approval to resume approach to the station from 250 meters, with the HTV having completed all of its near-field systems demonstration tests. Once the approach to the station resumes from 250 meters, the next arrival point will be at 30 meters for a final systems check before the HTV is given approval to move in within range of the grappling point or the capture point, where the station's robotic arm will reach out and capture the vehicle for its ultimate installation on the Earth-facing port of the Harmony module. The JAXA HTV flight director is wrapping up their analysis of one of the two redundant LiDAR navigation sensors. All of the data appears to be coming in line, and we should be getting approval shortly from Flight Director Fiona Antkowiak to resume approach from 250 meters. A good view of the thruster firings on the HTVX as it holds position 250 meters away from the International Space Station at a point directly below the station. HTVX has behaved very well, all of its systems functioning up to speed, and based on pre-flight expectations, in the 3.5 days that it has traveled from the launch pad at the Tanegashima Space Center in southern Japan to this point, ready to resume its final approach from 250 meters to the next stoppage point some 30 meters away from the station.
Station Houston on 2 for HTVX. SIPC and Houston are ready for HTVX approach inside the keep out sphere. Expect approach to resume shortly.
Station copies. Great news. Expecting approach to resume shortly.
And there's the confirmation relayed to Zena Cardman from Aki Hoshide here in Mission Control. The HTVX has checked out. Everything is in good shape, and we're ready to resume its approach from 250 meters inside the so-called keep-out sphere, which in layman's terms would be the close neighborhood toward the International Space Station. This brand new cargo craft joining the supply chain of other cargo vehicles, providing supplies, food, and fuel for the expedition crew members on board the station. Soon to be joining other vehicles attached to the station. We mentioned this earlier, but it's worth noting that once HTVX arrives at the station and is bolted into place later today, on the Earth-facing side of the Harmony module of the station, only one arrival port will be left open, that being the Rosviet module of the International Space Station. That's on the Earth-facing side of the Russian segment of the station, otherwise known as MRM-1. That port will be occupied on Thanksgiving Day when Soyuz MS-28 arrives with 2 Russian cosmonauts and NASA's Chris Williams. At that point, every single port will be occupied at the International Space Station. And of course, the arrival of HTVX coming just days before the 25th anniversary of a permanent human occupancy aboard the station that will be marked on Sunday, November 2nd.
Copy. Approach has resumed. We are starting step 5 of 1.102.
And HTVX once again on the move, departing 250 meters. We're about 12 minutes behind the timeline, with the extra time needed at the 250-meter mark.
Step 5, we have good lights on the HTVX command panel, and we will begin our Block Bravo calls.
Copy.
This will take some 30 minutes for HTV to traverse up the radial vector, again, the imaginary line drawn between the space station and the Earth, essentially a point directly below the station, before it reaches the 30-meter hold point.
Houston Station for Block Bravo. Using monitor 3, the light is within the corridor. Vehicle size matches the outline, though it is hard to see again now that we are in darkness. The light is 1/2 vehicle length forward from the circle and 1/4 vehicle width starboard from the circle. The circle is 1/2 length aft from the center of the corridor. Monitor 1 matches monitor 3.
Copy, good report, thanks. Station Houston on 2 for HTVX. HTVX is inside the 200-meter keep-out sphere. Crew now has authority to issue an abort if no comm with Houston and light outside the corridor. How copy?
Station copies. We are monitoring our retreat and abort criteria per 1.102, and HTVX is inside the 200-meter keep-out sphere.
Good copy.
Houston Station for Black Bravo.
Go for Bravo.
Using monitor 3, the light is within the corridor. Vehicle size matches the outline. Only changes currently are the light is 1/4 vehicle length forward and 1/8 vehicle width starboard from the circle. The circle is 1/2 vehicle length aft and 1/4 vehicle width starboard and moving further starboard from the center of the corridor.
Copy, good trending.
Monitor 1 matches monitor 3.
Copy that.
Zena Cardman reporting back data that she's seeing on her monitors in the cupola. She's alongside Kimiya Yui of the Japan Aerospace Exploration Agency as the HTVX moves up the so-called corridor, up the radial vector, now about 147 meters away from the station, closing at a rate of about 1/10 of a meter per second. This is essentially a methodical crawl for the HTVX up the radial vector, as all of its systems are being carefully evaluated prior to the time that it arrives within very, very close proximity of the station. There will be another hold point at 30 meters to assess its systems before it resumes its approach from the 30-meter hold point to what is called the capture point, about 10 meters away, some 32 feet away from the station. That's the point that a final assessment of the systems will be made before the approval is given for Kimiya Yui in the cupola to begin extending the Canadarm2 robotic arm towards a grapple fixture on HTVX.
Station Huntsville, Space to Ground 2 for Johnny and Payload Naz at your convenience.
Huntsville, Johnny 2, how can I help?
Hey, Johnny, we wanted to free you up to watch HTVX capture. So we are ready for you to perform your Payload Naz hard drive reseat whenever you'd like. Additionally, we were able to cut out about 30 minutes from this procedure. So step 1.3.2 in that procedure has you getting a go from us to verify 30 minutes have passed. We have already verified all that we need from that. So you are go to skip that step and move through your procedure. Should only take you about 10 minutes.
Hey, I'm Copy. I reviewed the procedures, and we are on the same wavelength. I was just going to ask if I could get that hard drive cooling done early. I understand the big intent behind this. I'm going to reseat the hard drives, which shouldn't take too long. Any more information maybe on the background of what signature you all are seeing on your end? I've got a couple NESs at home, so I'm wondering if I would be able to help, depending on what kind of signature you're seeing.
Yeah, so we're trying to correct an issue with one of the hard drives experiencing degradation and a logical ejection. All these hard drives are going to be reseated as a preventative action in case a similar issue is present on the other hard drives that we haven't noticed yet.
Copy. Do you know which hard drive is the one that's showing an off-nominal signature?
Yeah, that's hard drive 3.
Copy number 3. Okay, so I will go ahead and reseat them all per the procedure. I would I'm assuming this is a RAID setup, so maybe you might have to, if this doesn't work, replace that hard drive so the parity can rebuild. But I guess we can cross that bridge if we get there.
I will pass your words on to someone who is more technically savvy than I am, but we appreciate that.
Please have it help. Thanks for the support. I'll get it knocked out now.
Station for Block Bravo call.
Go on, Tube.
Our key changes are the vehicle continuing to trend further starboard. So differences from last time, the light is 1/4 vehicle forward from the circle, 1/8 vehicle with starboard from the circle. The circle itself is 1/2 vehicle with starboard from the center of the corridor and 1/4 vehicle length aft.
Copy all. Good report.
Once again, several conversations ongoing aboard the station. Johnny Kim of NASA talking to payload controllers at the Payload Operations Control Center at the Marshall Space Flight Center in Huntsville, Alabama. And Zena Cardman in the cupola of the International Space Station, along with JAXA astronaut Kimi Ayui, monitoring the slow but steady approach of HTVX up the radial vector from a point directly below the station. Currently 100 meters separating HTVX from its grapple point. Everything continuing to look good. No concerns. The visiting vehicle officer here in Mission Control and the HTVX flight director at their control room in Tsukuba, Japan, reporting that all of HTVX's systems are in excellent shape as it continues its very slow but deliberate approach to its final arrival point about 10 meters away from the complex. We are in between satellite coverage on our tracking and data relay satellite system. We'll get our downlink television capability from the station's external cameras back here shortly. Just to recap, HTVX launched from the Tanegashima Space Center in southern Japan atop an H-3 rocket by the Japan Aerospace Exploration Agency on Saturday night U.S. time, Sunday morning Japan time. The 3.5-day rendezvous for HTVX deliberately plotted out to test all of its brand new systems on this new cargo freighter prior to its arrival in close proximity to the station, which occurred very early this morning. Since then, a series of near-field demonstration tests of HTVX's systems have been conducted, with all of those systems passing muster. HTVX currently about 80 meters away now from the station, continuing to move to the next hold point at the 30-meter mark.
Houston Station for Block Bravo.
Granted.
Coming up on 60 meters. Using monitor 3, the light is within the corridor. Vehicle size matches the outline. The light is now just barely forward of the circle and centered port starboard relative to the circle. The circle is less than 1/4 vehicle width starboard and less than 1/8 vehicle length aft from the center of the corridor, all converging on the center of the corridor.
Copy. Good report. Thanks.
Zena Cardman reporting the relative position that she is seeing HTVX in as it moves up the corridor for its grapple point. All of that data appears to be in good shape. Some 56 meters now separating HTVX from the station. HTVX and the International Space Station are currently traveling 260 miles just west of HTVX's launch site at the Tanegashima Space Center.
And Johnny, we copy on 2. Apologies, I lost KU there. We copy that amber light. We're checking on it, but we'll let you know if we need anything else.
This is Mission Control Houston. HTVX is approaching the 30-meter hold point. Everything continuing to look good on the vehicle as it methodically makes its way from a point directly below the station to a capture point at about the 10-meter mark. There will be a hold point first at 30 meters to assess the HTVX's systems before it resumes its approach one final time to that capture point for a final assessment before Kimiya Yui uses the station's robotic arm to reach out and grapple the Japanese cargo ship that launched 3.5 days ago from the Tanegashima Space Center in southern Japan.
Station, no changes to our previous Block Bravo call.
Copy that, Zena, and be advised. So we did recover LiDAR 2, but it faulted again. So we're going to leave. We're going to be in this config for capture.
Copy. Understand. We'll be in this config for capture. No problem.
And that call from Aki Hoshide here in Mission Control to Zena Cardman, indicating that one of the two redundant LiDAR navigation sensor systems has been providing some erratic data to the onboard computers. So that has been evaluated here in Mission Control, as well as in the HTV flight control room in Tsukuba, Japan. It is of no concern. We're pressing ahead with the approach of HTVX for its grapple by Yui using the Canadarm2 robotic arm. And we now have confirmation that we have reached the 30-meter hold point.
Station Houston on 2 for HTVX. Confirm a 30-meter hold. Then set up and brief for capture per step 6 and 1.102.
The crew will receive a final briefing now from Mission Control here in Houston.
We can confirm 30-meter holds. Lights on the HTVX command panel match expected, and we will set up for capture per step 6 of 1.102.
Good words.
This will be about a 15-minute hold. The crew on board will be receiving a final briefing on procedures as HTVX traverses the final few meters for its capture. The HTV flight director in Tsukuba, Japan, reporting that they're happy with all of the vehicle systems. Flight director Fiona Antkowiak is about to take a final poll of her flight controllers here for resumption within 30 meters. And the crew will be receiving a short briefing on final procedures prior to the HTV closing the gap for its capture robotically by Kimiya Yui using the station's robotic arm. And a good view of the HTVX, just 30 meters away from the International Space Station, as the two fly in formation over the northeast Pacific, moving from northwest to southeast. This pass will take the two vehicles directly over Baja California a short time from now. HTVX carrying about 4.5 tons of supplies and experiments for the Expedition 73 crew aboard the International Space Station. HTVX holding steady, minutes away from reaching its final destination. And an even closer view of the new cargo vehicle. The HTVX made of two major components, a pressurized module and a service module. The service module contains the propulsion and guidance, navigation, control, communications, and power systems. 26 feet long, 14.5 feet wide, about to join the resupply chain at the International Space Station. And framed against the limb of the Earth, a good view of the HTVX in close proximity to the International Space Station. HTVX.
Station on 2 for HTVX. Per 1.110, step 3.2. Crew is ready for HTVX approach to capture point.
Copy all. Stand by. Station Houston on 2 for HTVX. HTVX is ready to proceed to the capture point. Expect approach to resume shortly.
We're handing over between satellites.
Station Houston on 2 for HTVX. HTVX is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies, ready to proceed to capture point, expecting approach to resume shortly.
So with that, Aki Hoshide informing Zena Cardman that the vehicle is ready to resume the final leg of its 3.5 day journey to its capture point, just about 10 meters away from the International Space Station. And the approach command has now been sent. HTVX and space station flying just off the west coast of the United States.
Station Houston on 2 for HTVX. HTVX has begun approach from 30 meters. Monitor per step 7 in 1.102.
Station copies, resuming the approach and monitoring per step 7 of 1.102.
The actual capture phase involves Kimiya Yui operating the station's robotic arm from the cupola, backed up by NASA's Zena Cardman. The end effector will move over the grapple pin. It will actually grapple HTVX, but the snares then will have to close, the carriage retracted, and that will mark the official capture time that we'll provide for you as soon as we have that data. HTVX closing in at a very glacial pace, some 28 meters away. "27 meters away.
Station on 2 for Block Bravo. Lights have converged on the center of the circle, and circle has converged on the center of the corridor.
Copy. Good report. Thanks.
This view now from the end effector camera on the station's Canadarm2 robotic arm. 25 meters separating HTVX from the arm. 23 meters now separating HTVX from the International Space Station. Just passing south of Baja California, moving from northwest to southeast. This is Mission Control Houston. Everything continuing to go very well as HTVX is about to close to within 20 meters of the International Space Station. You can see the Canadarm2 extended, ready to move in under the command of Kimiya Yui, operating from a workstation in the cupola, backed up by NASA's Zena Cardman. That arm will be set in motion once HTVX arrives at about the 10-meter mark. HTVX continues its methodical approach towards the end effector of the station's robotic arm. Now just 17 meters separating HTVX from the capture point. Once HTVX has been grappled, Kimiya Yui and Zena Cardman will hand over the robotic chores to the robotics officer here in Mission Control in Houston, who will spend the next several hours maneuvering HTVX toward the Earth-facing port of the Harmony module for its installation into the common berthing mechanism on that nadir side of Harmony, where HTVX will then be bolted into place. The crew will not be opening the hatch to HTVX until tomorrow morning to begin the process of unloading the start of the cargo operations. Some 4.5 tons of supplies and experiments arriving at the International Space Station. HTVX and the station flying from northwest to southeast over the Pacific Ocean, just off the coast of South America. Now just 14 meters separating the two vehicles. We're about 5 minutes away from arriving at the capture point. One final check of HTVX's systems before the approval is given for Kimiya Yui to begin extending the Canadarm2 toward the grapple fixture. "13 meters now separating HTVX and the station. Everything looking very good. HTVX's systems rock solid. HTVX and the International Space Station flying just off the coast of Peru. And a good view from the end effector camera on the Canadarm2 as you're looking right down the barrel of the grapple fixture that the Canadarm2 will affix itself to here a short time from now. The journey of HTVX that began 3.5 days ago with its launch atop JAXA's H3 rocket from the Tanegashima Space Center in southern Japan about to conclude. Now just 12 meters separating HTVX from the grapple fixture on the International Space Station's Canadarm2.
Station Houston on 2 for HTVX. Confirm capture point hold for step 8 in 1.102.
Houston Station, for step 8 of 1.102, we can confirm CP hold.
Houston copies.
This is Mission Control Houston. Aki Hoshide confirming with Zena Cardman that HTVX has reached one final hold point at the 10-meter mark. Now polling the flight controllers for a go, no-go to resume the operations that will involve Kimiya Yui extending the Canadarm2 from this 10-meter mark to the grapple fixture on HTVX to complete this rendezvous. HTVX is about to be placed into what is called free drift, inhibiting any further thruster firings so as not to perturbate the operation of the Canadarm2 robotic arm as it moves in to grapple the vehicle.
Station Houston 2 for HTVX. PVGF SEP is enabled. Prepare for capture per step 9 in 1.102.
Okay, we see PVGF SEP is enabled, and we are working step 9 of 1.102.
Houston copies.
Houston Station, per step 9, we can confirm command panel LED configuration is good and our capture preparations are confirmed. We are ready for HTVX capture with a preference to wait until the other side of this S-band handover.
Copy. And Houston copies, stand by for capture.
The S-band handover referred to by Zena Cardman is a brief gap in communications voice-wise. We do have solid downlink television capability. So we're just a couple of minutes away from Kimiya Yui beginning the work to extend the Canadarm2 robotic arm for its capture of the Japanese cargo ship that is completing its maiden voyage to the International Space Station. HTVX and the station currently flying over Argentina from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator, about to emerge off the east coast of South America over the South Atlantic.
And Station Houston on 2 for HTVX Xena. So that big gap in Optimus, we think that's conservative. It's going to be more like a 4-minute continuation and then a 20-second handover after that.
Okay, copy. That is great information. We can, with your go, start working step 4 of 1.110.
Okay, copy that. Stand by. We're doing the final pull on the ground.
We copy all.
Station Houston on 2 for HTVX. You are go for HTVX capture sequence. Perform step 4 in robotics procedure 1.110. Begin monitoring the backaway cue card.
Station copies. We are go for the capture sequence. We will start with step 4 of
And we're in that brief handover in S-band communications. But the approval has been given for Kimiya Yui to begin the work with the Canadarm2 robotic arm to extend it slowly and methodically toward the grapple fixture on the vehicle. And the International Space Station now in free drift. Thrusters disabled. Standing by for arm motion.
Houston Station on 2 for your awareness. We are doing translational alignment and then beginning our approach.
Copy, we're watching.
And the robotics officer reports the arm is now in motion. Four and a half meters. Good view from the end effector camera. Both vehicles are in free drift. Two and a half meters. One meter away, standing by for capture. We have initial capture. This is soft capture. Waiting for... We have initial capture. This is soft capture.
Thank you. ありがとうございます. Thank you for your heartwarming warm words. Thank you.
Waiting for... We have initial capture. This is soft capture. Between two
Thank you.
astronauts representing the Japan Aerospace Exploration Agency, Kim Yui, on board the station, part of Expedition 73. Relaying
We have initial capture.
This is soft capture. Between two astronauts representing the Japan Aerospace Exploration Agency, Kim Yui, on board the station, part of Expedition 73. Yui on radio. Soft capture. Two astronauts representing the Japan Aerospace Exploration Agency, Kim Yui, on board the station, part of Expedition 73. Common berthing mechanism. on the Harmony module for its installation and bolting into place later today. Those words acknowledged by veteran astronaut Aki Hoshide here in Mission Control, who himself used the Canadarm2 back in 2012 as part of Expedition 32 to capture the one of the original HTV vehicles, the HTV-3. So the work is now complete, with the exception of the maneuvering of the vehicle to its installation and bolting into place later today. The bottom line, a flawless rendezvous. Everything went by the book. All of HTVX's systems performed normally. Capture So with that, we will wrap up our coverage for today. Thank you for joining us this morning.
Common birthing
have a good day, the rest of this day and in the days to come. This is Mission Control Houston.
The International Space Station is the ultimate extreme home.
Space is an environment where human beings were not meant to live.
The most expensive structure humans have ever built. Here, in the most inhospitable environment known to man.
The only reason we can go there is by taking technology to provide us with everything that we need in order to stay alive.
With no air, food, or water, 250 miles above the Earth, it's an epic engineering challenge.
We as engineers are having to figure out how to make systems that provide all those functions that Earth provides in a tiny little can.
To reveal how the engineers pulled it off, we're going to take it apart and uncover what's going on inside. How the International Space Station and its superstructure secrets will help our species reach other planets and beyond. Costing up to an astonishing $150 billion. This is an unprecedented home.
The ISS is an extraordinary feat of engineering because not only do you have to make this big environment that people can live in, which, you know, is non-trivial to do on Earth, you have to do it in space.
It comprises millions of high-tech components. There are 16 pressurized modules with living quarters, sleeping bays, an observation deck, and 6 science labs, all connected via airtight tunnels. There's plenty of parking for visitors, including spots reserved for Russian Soyuz capsules, and the ISS's lifeboats, which are on permanent standby in case of emergency. Unlike any other structure, the ISS has to provide everything its astronauts need. If it fails, they die.
A human being can only survive for 3 weeks without food, 3 days without water, and 3 minutes without air.
For humanity to successfully venture well away from Earth, astronauts will need to be self-sufficient. If the ISS can solve the challenges, it will prove humans can truly live in space. But before anyone can take up residence, the engineers behind the ISS had to get it into space. And it weighs a colossal 460 tons. The same as about 300 cars.
It would be great if we could just build the International Space Station on the Earth and then just blast it into space.
You couldn't just fly the whole thing up there in one shot. You had to take a piece at a time and assemble it together like Lego.
The ISS began life as just 2 modules that had to be connected in space. One built by America and the other by Russia.
The first flight actually launched in November of 1998. Hadn't been that long since the end of communism in Russia, and here we were building a joint Russian-US space station. So just the political milestone that represented was pretty significant.
After the intense competition of the space race, it's suddenly all about collaboration. The orbiting Russian module is known as Zarya, which means sunrise. Next, the first American module, known as Unity, sets off inside the cargo bay of Space Shuttle Endeavour.
Liftoff of the Space Shuttle Endeavour.
Unity is now chasing Zarya through space at more than 17,000 miles per hour. 2 modules from 2 superpowers are about to dock.
First thing we have to do is to open up the payload bay doors.
Can you imagine how important it is for these 2 modules to mate?
Unfortunately, before both modules were launched, engineers spotted a problem.
Not all the pieces got to be integrated on the ground before they were launched.
Neither Zarya nor Unity were originally designed for the ISS. Their docking systems wouldn't fit together.
The Russian hatches are all round, and our hatches are all square.
I mean, this is fundamental to the International Space Station, and what you have are 2 things that don't mate.
And so, what do? Well, you make an Adapto-Lego block connector thing.
The L-shaped Lego thing they came up with is called the Pressurized Mating Adapter, or PMA. Not only does this accommodate the different shaped hatches, it also has a precision-engineered docking ring for grabbing hold of another module and perfectly aligning it. Vital if a reliable airlock is to be made. This is the moment of truth. Latches on the inside of the docking ring finally make the connection and pull the modules together.
Houston Endeavour, we have capture of Zarya.
The International Space Station is born.
It was amazing. I mean, here we are. We got airborne. We had Unity in the bay. And when we left a functioning space station ready for the next module to come up.
In the 20 years that follow, engineers from all around the world join the project, building their own space laboratories and bigger living quarters. But every one of the modules was constructed on Earth, and it takes a supreme international effort to launch them all successfully into space.
It took a long time to build Space Station. We have to fly everything up, we have to connect all the modules, put them together. So that took over 40 missions. Modules came from all over the world. We have the US modules from NASA, we have the Russian modules, we have the Japanese modules and the European module, you name it.
And it costs around $10,000 to send every pound of weight up here from Earth.
So right now, we're in the Japanese laboratory. It's